Hey guys, most of the measurements that we take are not perfect. For instance, maybe we want to measure the volume of a cylinder and we measure it at 9 milliliters, but it later turns out that the cylinder is actually 10 millimeters of space. Or maybe we want to measure the mass of a cube and we measure its mass at 105 grams, but it later turns out that the mass of the cube is 100 grams. Is that good? We were off by 5 grams, we were off by 1 milliliter. Is that bad? We were in the right ballpark. Well, what scientists use to gauge the accuracy of their measurements is a calculation called percent error, which is just how far away their measurement is from 100% perfect. Now this shouldn't be too foreign a topic for you because you do a version of this all the time in school. For instance, if you get 80 points right on a test, and there were actually 100 points available on the test, you do a simple ratio to determine that you got 80% on the test. You got 80% right. Now, if you wanted to figure out the percent error you got on the test, that is how far away you were from 100% perfect, and you got 80% of perfect, your percent error was 20%. You were off from 100% by 20%. So we can do the same thing for these two objects up top. If we have a measurement of the object of 9 millimeters, but the actual volume of the object turned out to be 10 millimeters, we can make a simple ratio, 9 millimeters over 10 millimeters, what we measured over the actual volume. And when you plug that into your calculator, you'll get a decimal of 0.9. To convert that into percent, just move the decimal place 2 places to the right, and you'll find that our measurement was equal to 90% of the actual volume. So the percent error of our measurement was how far away our measurement was from 100% perfect. We got 90% of the actual volume. Our percent error was 10%. Specifically, we put this minus here because we were 10% short of the perfect answer. We were 10% too low, too small. Let's do the same thing for object B. If we measured object B at 105 grams, but the actual mass was 100 grams, we can make a ratio of our measured mass to our actual mass, which when we plug into a calculator, we can find reduces to a number of 1.05. To convert this to percent, we just shift the decimal places 2 places to the right. We find out that our measurement was actually 105% of the actual mass. So our percent error, how far away our measurement was from 100% perfect, well, we got 105%. We were actually too high. Our percent error was 5% too high. Generally speaking, scientists consider their measurements accurate if they're within 5%.